This set of problems is just like those in Learning Objective 11.2, but this time we're doing bigger, more interesting molecules. So all we need to remember is that every end of a line segment is a carbon. So every corner is a carbon. I'll start with this one down here. And when we have a heteroatom that's not carbon or hydrogen, we just write it. This is our structure of minoxidil, which is used in hair loss prevention medicines like Rogaine. These all had single bonds, so I drew them with single bonds. Go up here with a single bond. Now I've got a double to another carbon. So this has alternating double bonds. It's an aromatic ring, whereas this down here is a saturated ring, just alkyl ring. So it would have a name like cyclo, whereas this would have something like benzene, or there are many other names. Oh, and I messed up one. This here should be an N. That's going to make a difference for the H's we draw in. Over here we go to an N, H2. I'm going to expand it right now. All right, this N has a plus on it. Plus reminds us it's missing an electron. This O has a minus on it, although it's rather small. Tells us it has an extra electron. Okay, so we can start filling in the hydrogens. 3 bonds, 1 hydrogen. 4 bonds, no hydrogen. 3 bonds, nitrogen likes 3 bonds. It has a lone pair there. I'm going to put another lone pair here. This already has 8 electrons, no lone pair. This here has 2. To get that minus charge, needs an extra electron, so 3 lone pairs on that oxygen. Come down here. This nitrogen needs a lone pair to go with its 3 bonds. Carbon with 2 bonds needs 2 hydrogen, and we'll do that all the way around. So when a chemist looks at this line angle structure, this skeletal structure, they're able to fill in their mind all the rest of this. But here it's much cleaner. You can see all of the nitrogen and the oxygen, these functional groups really stand out. This aromatic ring really stands out. And you may have caught that I made another mistake. That's an N with 2 H's. So another amine group. All right, moving over to Prozac, an antidepressant molecule. I'll give myself extra space since I'm writing so big. I'm going to connect these 3 fluorine and have a name like trifluoro if we add the official name. I'll draw my 6 carbon in the aromatic ring, and then I'll draw the bonds after, alternating single and double, and it would be okay if I switched their location compared to where they are in the structure there, because there's resonance, they move around. They actually don't move around, they're just shared around that whole group. Bond to an O, to another C, another C, I'm going to give myself a C here, visually help me remember where that branches off. And I've got an N, it's got an H, and a bond with nothing. That means there's a C there. So our N has all three. Okay, let's come back to this aromatic group. My 6 carbon, and as I said, it wouldn't matter if I switched where the double bonds are drawn because of resonance. Okay, I've got all of the backbone done, and functional groups, oxygen needs 2 lone pairs, although sometimes these are drawn without the lone pairs. Okay, just go in and add the hydrogen. 1 each around the aromatic ring, except where they've got something else bound. This carbon has 1, 2, 3, so it's still going to have another hydrogen. This one will have 2. This will have 2. And 1 to each of these around the second aromatic ring. A technical note for anyone wanting to understand this at the next level: this carbon here with 4 different groups attached has stereochemistry about it. So the molecule should specify, most drugs stereochemistry matters, so the molecule should specify what the stereochemistry is, and it doesn't here. So that's something you could go and look up and learn about.